Hi everyone, I am Dr. Peiris. Today I am going to explain you about the standard form of the quadratic functions. In this topic, first I will show you what is the standard form of a quadratic function. Then I am going to relate the standard form to the characteristic of the parabolas. So we basically learn how to find the intercepts, vertex and the axis of symmetry if the quadratic function is given in terms of the standard form. Then we will see how to graph the parabolas. So what is the standard form of a quadratic function? It is basically in this form: f of x equals a x minus h squared plus k. A, h and k are real numbers and the a is not equal to 0. So to have a quadratic function, the a cannot be equal to 0. And this is an example of a quadratic function: 2 times x minus 1 squared minus 8. So if we compare this one with the standard form, we see that the a is equal to 2 and the h is equal to 1, k is equal to negative 8. So one thing to remember, the h has a negative sign and the k is a positive sign. So it must be remembered when we obtain the values for the h and k. We need to compare it to the signs in the given standard form. Now let's see what are the characteristics of parabolas. So basically, if we graph a quadratic function, it gives a parabola. It is a shape of a parabola, and this is a parabola which opens upward, and here is the axis of symmetry. So if you look at the graph of the parabola is symmetric on this axis of symmetry. So the parabola is symmetric about the axis of symmetry, and the bottom point is the vertex because this is open upward. So in some cases we will have the parabolas going like this. It means the parabola opens downward. So in that case we will have a maximum. So that would be the vertex for that particular case. So the vertex is basically the minimum or the maximum point in the parabola. And the x coordinate of the vertex is given using the h comma k. So if the equation is a times x minus h squared plus k, the vertex is always h comma k. If the vertex is h comma k, the x coordinate of the vertex is h. So if the x coordinate is h, which means the axis of symmetry also equal to h. So the axis of symmetry is x equals h. So why this is x equals? Because this is a vertical line which crosses the horizontal axis or the x-axis. So the axis of symmetry is a vertical line which is given by x equals h. And to find the x-intercept, so these are the x-intercepts. To find the x-intercepts, we substitute y equals 0 or f of x equals 0, because at these x-intercepts the y values are 0. And then how do we find the y-intercept? So at the y-intercept, the x value is 0. So to find the y-intercept, we substitute x equal 0. Now let's see how do we graph parabolas if we have given the quadratic function in terms of the standard form. So first thing that we need to find the intercepts. So to find the y-intercepts, we substitute x equals 0 in the given quadratic function. So let's find the y-intercept. So substitute x equals 0. 0 plus 1 squared minus 2. So I basically substitute x equals 0 here, and then we need to simplify this to find the y-intercept. So 1 squared is 1, 1 minus 2 is negative 1. So the y-intercept is 0 comma negative 1. To find the x-intercepts, we substitute f of x equals 0, or basically we make y equal 0. So this part is equal to 0. 0 equals x plus 1 squared minus 2. Then we need to solve for x. So this here way to solve for x is to isolate this square term, because all the time we're going to have this square term when the quadratic function is given in the standard form. So we need to isolate this square term. So to do that, we bring the 2 to the other side, which becomes plus 2 x plus 1 square. Now we have a square on the right hand side, which means to get rid of this square, we take the square root both sides. So if we do the square root of the x plus 1 squared, it becomes x plus 1, and this side becomes square root of 2, and it could be plus or minus. So don't forget to put plus or minus, it could be plus or minus. Now to solve for x, we subtract 1 from both sides, so x is equal to negative 1 plus or minus radical 2. So these are the x-intercepts, negative 1 plus radical 2 and negative 1 minus radical 2. So this is the x-intercepts, and we found the y-intercept also. Now let's see how do we graph the parabola. So the first thing is to understand, is the parabola going to open up or down? So that depends on the value of the a. If the a is greater than 0, the parabola opens upward. So if we look at this, the given quadratic function, the a is equal to 1, which is greater than 0, so the parabola opens upward. And what is h and k? Or basically we need to find the vertex. So the h need to be minus 1, because in the original formula we have x minus h squared plus k, which means the h need to be negative 1 and the k is negative 2. So if the h is negative 1, the axis of symmetry is negative 1. The vertex is simply h comma k, which is negative 1 comma negative 2, and we found the x-intercepts as well as the y-intercept. Now we have everything that we need to graph the parabola. So we're going to start with drawing the axis of symmetry, which is at x equals negative 1. So here is the axis of symmetry. Then the vertex is negative 1 comma negative 2. So here is the vertex. Then we mark the intercepts. The y-intercept is at 0 comma negative 1. This is the y-intercept. Now we need to mark the x-intercept. So the x-intercept is negative 1 radical 2. So we all know that the radical 2 is close to 1.414 something. So if we do that, so negative 1 plus radical 2, which is going to be 0.414. So this means right here I have one x-intercept. The other intercept is negative 1 minus radical 2. So negative 1 minus 1.414, which is minus 2.414. So right here is minus 2.414. Now we have everything, so we just need to connect the dots. Make sure when you draw the curve, it looks like a parabola, and it cannot be straight lines, it has to be a curve. And once you draw it, you're supposed to see that your parabola is symmetric about the axis of symmetry. So this is how we can easily graph the parabolas when the quadratic function is given in the standard form. So let's see another example. So this is the second example. So again we are going to find the intercepts first. So to find the y-intercept is substitute x equals 0 in here. X equals 0, 2 times 0 minus 1 squared plus 3. Then we simplify this. So negative 1 squared is positive 1 times 2 is 2. 2 plus 3 is 5. So that is the y-intercept at 0 comma 5. To find the x-intercept, we make f of x equal to 0. 0, 2 times x minus 1 squared plus 3. So again we need to isolate the square term to find the x. So to isolate the square term, we first subtract minus 3 from both sides. This is minus 3. 2 times x minus 1 squared. Then we need to get rid of the 2, so we divide by 2. X minus 1 squared equals minus 3 over 2. So what do we get in this case? We get a square equal to a negative value. So which means if we take the square root, we are taking the square root of a negative value, which is basically an imaginary number. So since we are getting a negative number in this case, so once we take the square root, we are getting an imaginary answer. So which means there are no real roots, so there is no x-intercept. So in this case there is no x-intercept, because we are getting a square root of a negative value. If we want to find the x value, so we take the square root both sides. So if you take the square root on this side, it becomes x minus 1, and the square root of this side becomes the square root of negative 3 over 2, which is imaginary. So this is going to be imaginary, which means there are no real roots, so there is no x-intercept in this case. So we found both y and the x-intercepts. Now let's go and see what are the values for the vertex and the axis of symmetry. So we look at first what is the value of the a, which is 2 greater than 0. So the parabola opens upward, h is equal to 1, k is equal to 3. So if the h is 1 and k is 3, the axis of symmetry is equal to x equals 1. The vertex is h comma k, so 1 comma 3. And we found no x-intercepts and the y-intercept to be 0 comma 5. So let's draw the axis of symmetry first, which is at x equals 1. And then the vertex 1 comma 3. So here is the vertex at 1 comma 3. Then no x-intercepts, the y-intercept is 0 comma 5. So you can see why there is no x-intercepts, because here is the vertex and this is the minimum point, because the parabola opens upward. So in this case we have only 2 points right now, so we at least need another point on this side to make it proper. So you have at least 3 points in your graph. So how do you find the other point on this side? You can basically look at the left hand side, because we know the parabola is symmetric. So we must have a similar point on the right hand side, similar to this point over here. So this point is at 5, but within 1 units on the x-axis from the axis of symmetry, which means we should have a similar point on the right hand side within 1 units of the x-axis, and the value should be equal to 5. Now you have all the 3 points, so you can draw the parabola. Or the other thing to find a point on this side is you can choose any x value on that side and then substitute in here and then find the corresponding y value. That is another way to find the third point on that side. And this is another example. So let's find the y-intercept. So we substitute x equals 0 first to find the y-intercept. F of 0 minus x is 0 minus 2 squared plus 1. So then we have negative 2 squared becomes positive 4, and then it becomes negative 4 plus 1, which is negative 3. So that is the y-intercept. Y-intercept is at 0 comma negative 3. And then to find the x-intercept, we substitute f of x equals 0 minus x minus 2 squared plus 1. Now to isolate this square, x minus 2 square, we subtract 1 from both sides, so it becomes negative 1 minus x minus 2 squared. Now we can get rid of the minus sign on both sides, then it becomes 1 x minus 2 squared. Then we take the square root on both sides, so plus or minus, square root of 1 is 1. So which means x is equal to, so you bring the 2 to this side, which becomes plus 2. So we have 2 plus or minus 1. So which means x is equal to 2 plus 1, or x is equal to 2 minus 1. So 2 plus 1 is 3, 2 minus 1 is 1. So the x-intercepts are at 3 and 1. So 2 x-intercepts, one is at 1, the other one is at 3. So in this case, the value of the a is negative 1. If you look at the value, it is a minus sign, which means a is equal to negative 1. So which is less than 0. So the parabola opens downward. And the h is equal to 2, the k is equal to 1. Which means the axis of symmetry is x equals 2. The vertex is h comma k 2 comma 1. And we found the x-intercepts 3 comma 0 and 1 comma 0. As well as we found the y-intercept 0 comma negative 3. Now let's draw the axis of symmetry first, which is at x equals 2, and the vertex is 2, 1. So here is the vertex. X-intercepts 3, 0 and 1, 0. The y-intercept 0, -3. So you can see that how the points look like. They basically going down, so which makes sense because we know that the parabola opens downward. Now we simply draw the parabola. So this is a parabola which opens downward. So it's the same method you can use for any type of question to draw the parabola, and then to identify the axis of symmetry, the vertex, and how to find the intercepts. So that's all for today, everyone. So please subscribe to my YouTube channel, Dr. Peiris Classroom, for other videos, as well as visit my website drpeirisclassroom.com. You can find other videos for different classes. Thanks for watching, everyone. I'll meet you again with another video.